Terra-Dome Corporation is a well-established company specializing in the design and construction of underground concrete homes for over 40 years. These homes are known for their durability, energy efficiency, and disaster resistance. Underground houses offer several advantages, including protection from extreme weather events, reduced energy costs due to consistent temperatures, enhanced privacy and security, and a unique design. When considering electrical work, installing conduit in concrete walls, while not uncommon for underground construction, presents challenges. Firstly, there is difficulty of access. Running conduit in concrete walls requires specialized tools and techniques and can be time-consuming. Secondly, repairs can be difficult. If a conduit is damaged, it can be challenging to repair or replace it without disrupting the concrete structure. Thirdly, thermal expansion is a factor. Concrete expands and contracts with temperature changes, potentially stressing conduit and connections over time. The amount of wiring specified for a garage with 14 receptacles raises concerns. It's crucial to ensure the electrical system is properly designed and installed to avoid issues. This includes overloaded circuits, electrical fires, and trip breakers. In addition to electrical concerns, other factors must be considered. One is ventilation. Proper ventilation is crucial to prevent moisture buildup and ensure a healthy indoor environment. Another is waterproofing. The concrete structure must be well waterproofed to prevent leaks and moisture penetration. Fire safety measures must be carefully planned and implemented to mitigate the risks associated with underground construction. If you are considering building an underground concrete home, it is highly recommended to thoroughly review the plans and specifications to identify any potential concerns or challenges. Consult with a qualified electrician to optimize the electrical system design and installation, and consider the importance of ventilation, waterproofing, and fire safety. It is also recommended to request references from previous clients and ensure the builder has a proven track record of successful underground construction projects. When evaluating the electrical plans for an underground home, several crucial factors demand careful attention. Proper planning, adherence to electrical codes, and the selection of appropriate materials are essential for a safe and efficient electrical system. Here's a detailed breakdown of the key considerations for the electrical plan. The first thing to consider is the load calculation. Accurate load calculations are paramount to ensure the electrical system can handle the anticipated demand. This involves determining the total amperage required for all appliances, lighting, and equipment within the house. It's crucial to account for both continuous and non-continuous loads, adhering to the National Electrical Code, or NEC, guidelines for load calculations. The second thing to consider is the circuit design. The circuit design should incorporate an appropriate number of circuits to distribute the electrical load evenly. Overloaded circuits can lead to trip breakers, overheating, and potential fire hazards. Dedicated circuits should be provided for high-demand appliances such as refrigerators, air conditioners, and electric heaters. Ground fault circuit interrupter, or GFCI, protection is essential in areas prone to moisture, such as bathrooms, kitchens, and outdoor receptacles. Arc fault circuit interrupter, or FSI, protection is also recommended for bedroom circuits to mitigate the risk of electrical fires. The third thing to consider is the conduit type and sizing. Selecting the correct conduit type and size is critical for protecting electrical wiring within concrete walls. Rigid metal conduit, or RMC, or intermediate metal conduit, or IMC, are commonly used in concrete construction due to the durability and resistance to physical damage. The conduit size should be sufficient to accommodate the number and size of conductors required for each circuit, following NEC guidelines for conduit fill. The fourth thing to consider is the wiring methods. The wiring methods used within the conduit must comply with NEC standards. Individual conductors, such as THHN or THWN, are typically used within conduit. The wire gauge should be appropriate for the circuit amperage, ensuring adequate ampacity and minimizing voltage drop. All wiring connections must be made within approved electrical boxes and properly secured to prevent loose connections. Fifth thing to consider is the grounding and bonding. A robust grounding and bonding system is essential for electrical safety. A grounding electrode system consisting of ground rods or ground ring should be installed to provide a low impedance path for fault current. All metal components of the electrical system, including conduit, electrical boxes, and equipment enclosures, must be properly bonded to the grounding system. A main bonding jumper should connect the neutral conductor to the grounding electrode system at the service entrance. The sixth thing to consider is the lighting design. The lighting design should provide adequate illumination for all areas of the house while minimizing energy consumption. Consider using energy-efficient LED lighting fixtures to reduce electricity costs and improve energy efficiency. Recessed lighting fixtures installed in concrete ceilings must be IC rated or insulation contact rated to prevent overheating. Lighting controls, such as dimmers and occupancy sensors, can further reduce energy consumption and enhance convenience. The seventh thing to consider is the receptacle placement. Receptacles should be strategically placed throughout the house to provide convenient access to electrical power. The NEC specifies minimum receptacle spacing requirements for habitable rooms, ensuring that no point along the wall line is more than 6 feet from a receptacle. Receptacles installed in garages should be GFCI protected to prevent electrical shock hazards. The eighth thing to consider is the panel board selection. The panel board, or electrical panel, serves as the central distribution point for electrical power within the house. The panel board should be sized appropriately to accommodate the total number of circuits required. It's essential to select a panel board with sufficient spare capacity for future expansion. The panel board should be located in an accessible location away from moisture and flammable materials. The ninth thing to consider is the surge protection. Surge protection devices, or SPDs, should be installed to protect sensitive electronic equipment from voltage surges caused by lightning strikes or power fluctuations. A whole house surge protector should be installed at the service entrance to protect the entire electrical system. Additional SPD can be installed at individual outlets to protect specific devices. The 10th thing to consider is the compliance with codes and standards. All electrical work must comply with the latest edition of the NEC and any applicable local codes and regulations. A qualified electrician should be hired to perform the electrical installation and ensure that all work is inspected and approved by the local electrical inspector. The electrical plan should be thoroughly reviewed by the electrician and the building inspector to identify any potential issues or discrepancies before construction begins. By carefully considering these factors, you can ensure that the electrical system for an underground concrete home is safe, reliable, and efficient. Remember, consulting with experienced professionals such as electrical engineers and licensed electricians is crucial for a successful project. Furthermore, special attention needs to be paid to several unique aspects of underground home construction when designing the electrical system. These considerations include moisture control, ingress protection, thermal management, and accessibility for future maintenance and repairs. Let's delve deeper into each of these aspects. Firstly, moisture control is paramount in underground construction. The surrounding earth can introduce moisture into the structure, potentially damaging electrical components and creating safety hazards. To mitigate moisture-related risks, it's essential to use moisture-resistant wiring and conduit. THWN or XHHW-2 type wires are suitable choices as they are designed to withstand wet environments. Conduit systems should be sealed to prevent moisture from entering and accumulating. Consider using condensation-reducing fittings and sealants to further enhance moisture protection. Additionally, ensure that all electrical boxes and enclosures are NEMA rated for wet locations. Proper ventilation and dehumidification systems can also help control moisture levels within the underground home. Secondly, ingress protection is closely related to moisture control but extends to preventing the entry of dust, dirt, and pests. Underground environments can be prone to these contaminants, which can compromise the performance and safety of electrical equipment. NEMA-rated enclosures provide varying degrees of protection against solid objects and liquids. Choose enclosures with appropriate NEMA ratings based on the specific location and potential exposure. For example, enclosures installed in direct contact with the earth should have a higher NEMA rating than those located in a dry, interior space. Seal all conduit entries and openings to prevent the ingress of dust and pests. Thirdly, thermal management is a crucial consideration due to the stable but potentially cool temperatures in underground environments. While underground homes benefit from consistent temperatures year-round, it's essential to ensure that electrical equipment operates within its specified temperature range. Some electronic components may be sensitive to low temperatures, which can affect the performance and lifespan. Consider using thermally protected or temperature-compensated devices in critical applications. Proper installation around electrical boxes and enclosures can help maintain a stable temperature. Additionally, ensure adequate ventilation to prevent heat buildup in enclosed spaces. Fourthly, accessibility for future maintenance and repairs is a significant challenge in underground construction. Once the concrete is poured, accessing electrical wiring and equipment becomes difficult and costly. Therefore, careful planning and installation are crucial to minimize the need for future repairs. Use high-quality materials and components to ensure long-term reliability. Install access panels and pull boxes at strategic locations to facilitate future maintenance and modifications. Maintain detailed as-built drawings of the electrical system, including conduit runs, wiring diagrams, and equipment locations. Consider using modular wiring systems that allow for easy replacement or addition of circuits. Implementing a comprehensive maintenance program, including periodic inspections and testing, can help identify potential problems early and prevent costly repairs. In addition to these considerations, there are several other best practices for electrical installations in underground concrete homes. These include using corrosion-resistant materials such as stainless steel or PVC-coated conduit to prevent corrosion caused by soil chemistry. Labeling all circuits and equipment clearly to facilitate identification and troubleshooting. Providing backup power systems such as generators or battery storage to ensure uninterrupted power supply during outages. Installing lightning protection systems to protect against lightning strikes. Coordinating the electrical installation with other trades such as plumbing and HVAC to avoid conflicts and ensure a smooth construction process. Obtaining all necessary permits and inspections to comply with local building codes and regulations. By addressing these unique aspects of underground home construction and following best practices for electrical installations, you can create a safe, reliable, and efficient electrical system that will serve the home for many years to come. It's important to consult with experienced professionals who have expertise in underground construction and electrical systems to ensure a successful project. Let us consider the specific scenario of installing 14 receptacles in a two-car garage, which raises some concerns about potential electrical overload. To properly address this, several factors need careful evaluation, including load calculations, circuit design, receptacle spacing, and compliance with the electrical codes. First, let's delve into load calculations. The NEC provides guidelines for calculating the load for receptacles in garages. According to NEC section 220.14, each receptacle outlet in a garage is typically considered to have a load of not less than 180 volt amps. Therefore, for 14 receptacles, the total load would be 14 multiplied by 180, which equals 25 20 volt amps. This value represents the minimum load that must be considered when designing the circuit. However, it's essential to account for the actual loads that will be connected to these receptacles. If power tools, electric vehicle chargers, or other high-demand equipment will be used, the load calculation should be adjusted accordingly. Consult with a qualified electrician to determine the appropriate load calculation based on the specific usage patterns of the garage. Secondly, let's consider circuit design. Based on the load calculation, the number and size of circuits needed to supply the 14 receptacles can be determined. A typical 15 amp circuit can handle a continuous load of up to 12 amps, while a 20 amp circuit can handle up to 16 amps. To avoid overloading the circuits, it's generally recommended to divide the receptacles among multiple circuits. For example, 2 20-amp circuits or 3 15-amp circuits could be used. Each circuit should be protected by a circuit breaker of the appropriate size. It's also essential to ensure that the wiring is of the correct gauge for the circuit amperage. The NEC provides tables that specify the minimum wire gauge for different ampacities. Using undersized wiring can lead to overheating and potential fire hazards. Thirdly, let's address receptacle spacing. The NEC specifies minimum receptacle spacing requirements for garages. According to NEC section 210.52, at least one receptacle outlet must be installed in each vehicle bay and not more than 12 feet apart. This ensures that there are readily accessible receptacles for plugging in tools and equipment. It's also recommended to install receptacles near workbenches or other areas where power is frequently needed. The placement of receptacles should be carefully planned to avoid the use of extension cords, which can be a safety hazard. Fourthly, let's talk about compliance with electrical codes. All electrical work must comply with the latest edition of the NEC and any applicable local codes and regulations. A qualified electrician should be hired to perform the electrical installation and ensure that all work is inspected and approved by the local electrical inspector. The electrical inspector will verify that the installation meets all code requirements and is safe for use. In addition to these considerations, there are several other best practices for installing receptacles in the garage. These include using GFCI-protected receptacles to prevent electrical shock hazards, especially in damp or wet locations. Installing weatherproof receptacles if the garage is exposed to the elements. Using tamper-resistant receptacles to prevent children from inserting objects into the slots. Labeling all circuits and receptacles clearly to facilitate identification and troubleshooting. Providing adequate lighting in the garage to improve visibility and safety. By carefully evaluating these factors and following best practices, you can ensure that the installation of 14 receptacles in a 2-car garage is safe, reliable, and compliant with electrical codes. Remember, consulting with a qualified electrician is essential for a successful project.